Good morning, dear students. My name is Farhan Mazhar, and the subject today we are studying is Cambridge O Levels Physics 5054. Today, in this video, we are doing the revision checklist for the upcoming exam. And for this, we have a document which was issued by the Cambridge for the exams which are starting from 2023. So in this video, we are going to concentrate on the first topic of the syllabus of the Physics 5054. And the name of the topic is Motion, Forces, and Energy. So let's start. Okay, so here we go. So for the revision checklist, in this guide, which we are going to use, have provided some revision checklists. These includes information from the syllabus that you should revise. They don't contain all the detailed knowledge you need to know, just an overview. For example, for more detail, see the syllabus and talk to your teacher. The table headings are explained below. Here we have 4 columns, and in the first column, we will have topic. These are the topics you will study. In the second column, you should be able to. And this contains contents in the syllabus you need to cover. Here we will have, in the third column, we will have tick boxes where you have to tick, and you can use the tick boxes to show when you have revised an item and show and how confident you feel about it. Here the R is red, means you are really unsure and lack confidence. You might want to focus your revision here and possibly talk to your teacher for help. A stands for amber, means you are reasonably confident but need some extra practice. G here stands for green, means you are very confident. As your revision progresses, you can concentrate on the red and amber items in order to turn them into green items. You might find it helpful to highlight each topic in red, orange, or green to help you prioritize. The fourth column is of the comments. You can add further information of your own, add learning aids such as rhymes, poems, or word play, pinpoint areas of difficulty you need to check further with your teacher or textbook. Include reference to a useful resource. I will upload this. This is actually learning guide for examination from 2023 for the Cambridge O Levels Physics 5054 issued by the Cambridge. I will put the link of this file in the description of this video. You can download that file and then you can use it. You can share it with your teachers. You can share it with your friends, your class fellows, senior, junior students. Okay, the table below cannot contain absolutely everything you need to know, but it does use examples where it can. So the first topic, the name of that portion is motion, forces, and energy. The first topic is physical quantities and measurement techniques. You should be able to describe how to measure a variety of lengths with appropriate precision using tapes, rulers, and micrometers, including reading the scale on an analog micrometer. Describe how to use a measuring cylinder to measure the volume of a liquid or finding the volume of a solid by displacement. Describe how to measure a variety of time interval using clocks and digital timers. Determine an average value for a small distance and for a short interval of time by measuring multiples, including the period of a pendulum. Understand that a scalar quantity has magnitude, which is size, only, and that a vector quantity has magnitude and direction. Know that the following quantities are scalars: distance, speed, time, mass, energy, temperature, and pressure. Know that the following quantities are vectors: displacement, force, weight, velocity, acceleration, momentum, electric field strength, and gravitational field strength. Determine by calculation or graphically the resultant of two vectors at right angles. The second topic is motion. So the second topic is motion. He says you should be able to define speed as distance traveled per unit time and velocity as change in displacement per unit time. Recall and use the equation speed is equals to distance divided by time. V is equals to S divided by T. Recall and use the equation average speed is equals to total distance traveled divided by total time taken. You should be able to define acceleration as change in velocity per unit time. Recall and use the equation acceleration is equals to change in velocity divided by time taken. A is equals to delta V by delta T. State what is meant by and describe examples of uniform acceleration and non-uniform acceleration. Know that a deceleration is a negative acceleration and use this in calculations. Sketch, plot, and interpret distance, time, and speed time graphs. Determine from the shape of a distance time graph when an object is at rest, moving with constant speed, accelerating, decelerating. Determine from the shape of a speed time graph when an object is at rest, moving with constant speed, moving with constant acceleration, moving with changing acceleration. State that the acceleration of free fall g for an object near to the surface of the earth is approximately constant and is approximately 9.8 meter per second square. This number is very important. Before the exams of 2023 in the Cambridge O level, we were taking the g value as 10 meter per second square, but now we will take it as 9.8 meter per second square. Calculate speed from the gradient of a distance time graph. Calculate the area under a speed time graph to determine the distance traveled for motion with constant speed or constant acceleration. Calculate acceleration from the gradient of a speed time graph. Next topic is mass and weight. You should be able to state that mass is a measure of the quantity of matter in an object at rest relative to the observer. State that the mass of an object resists change from its state of rest or motion, that is inertia. Know that weights and therefore masses may be compared using a beam balance or equilibrium balance. Equal arm balance, sorry, I said equilibrium. Equal arm balance. Describe how to determine mass using an electronic balance. Describe how to measure weight using a force meter. Define gravitational field strength as force per unit mass. Recall and use the equation gravitational field strength is equals to weight divided by mass. Small g is equals to W by m. And note that this is equivalent to the acceleration of free fall. State that a gravitational field is a region in which a mass experiences a force due to gravitational attraction. The next topic is density. Define density as mass per unit volume. Recall and use the equation density is equals to mass divided by volume. Rho equals to W by V. Describe how to determine the density of a liquid for a regular shaped solid and of an irregularly shaped solid which sinks in a liquid volume by displacement, including appropriate calculations. The next topic is forces, balanced and unbalanced forces. You should be able to identify and use different types of forces, including weight, which is gravitational force, friction, drag, air resistance, tension, which is elastic force, electrostatic force, magnetic force, thrust, driving force, and contact force. Identify forces acting on an object and draw free body diagrams representing the forces. State Newton's first law as an object either remains at rest or continues to move in a straight line at constant speed unless acted on by a resultant force. State that a force may change the velocity of an object by changing its direction of motion or speed. Determine the resultant of two or more forces acting along the same straight line. Recall and use the equation resultant force is equals to mass multiply acceleration. F is equals to ma. State Newton's third law as when object A exerts a force on object B, then the object B exerts an equal and opposite force on object A. Understand that Newton's third law describes pairs of forces of the same type acting on different objects. The next topic is friction, and you should be able to describe friction as a force that may impede motion and produce heating. Understand the motion of objects acted on by a constant weight or driving force with and without drag, including air resistance or resistance in a liquid. Explain how an object reaches terminal velocity. Define the thinking distance, braking distance, and stopping distance of a moving vehicle. Explain the factors that affect thinking and braking distance, including speed, tiredness, alcohol, drugs, load, tire surface, and road conditions. The next topic is elastic deformation. You should be able to know that forces may produce a change in size and shape of an object. Define the spring constant as force per unit extension. Recall and use the equation spring constant is equals to force divided by extension. K is equals to F by X. Sketch, plot, and interpret load extension graph for an elastic solid and describe the associated experimental procedure. Define and use the term limit of proportionality for a load extension graph and identify this point on the graph. An understanding of the elastic limit is not required. Circular motion. This is the next topic. You should be able to describe qualitatively motion in a circular path due to a force perpendicular to the motion as speed increases if forces increases with mass and radius constant. Radius decreases if forces increases with mass and speed constant. An increased mass requires an increased force to keep speed and radius constant. F is equals to, that is the centripetal force, mv squared divided by r. This formula is not required. The next topic is turning effect of forces. You should be able to describe the moment of a force as a measure of its turning effect and give everyday examples. Define the moment of a force as moment is equals to force multiply perpendicular distance from the pivot. Recall and use this equation. State and use the principle of moments for an object in equilibrium. Describe an experiment to verify the principle of moments. The next topic is center of gravity. State what is meant by center of gravity. Describe how to determine the position of the center of gravity of a plane lamina using a plumb line. You should be able to describe qualitatively the effect of the position of the center of gravity on the stability of simple objects. The next topic is momentum, and this is the new topic which is added into the syllabus of the Physics 5054. You should be able to define momentum as mass multiply velocity. Recall and use the equation P is equals to mv. Define impulse as force multiply change in time. Recall that and use the equation impulse is equals to force multiply change in time, and that will be equals to change in momentum. Apply the principle of the conservation of the momentum to solve simple problems in one dimension. Define resultant force as the change in momentum per unit time. Recall and use the equation resultant force is equals to change in momentum divided by time taken. F is equals to delta P divided by delta T. So this is that topic momentum, very, very important that what you should be able to do. Okay, the next topic is energy, work, and power. So energy, state, you should be able to state that energy may be stored as kinetic, gravitational potential, chemical, elastic, which we also call strain, nuclear, electrostatic, magnetic, and internal, which we also call thermal. Describe how energy is transferred between stores during events and processes, including examples of transfer of forces, mechanical work done, electrical currents, electrical work done, heating, and by electromagnetic sound and other ways. Know that the principle of the conservation of energy and apply this principle to the transfer of energy between stores during events and processes. Recall and use the equation of the kinetic energy. Kinetic energy is equals to half mv square. Recall and use the equation of the change in gravitational potential energy. So the change in the gravitational potential energy is mg delta h. The next topic is work. You should be able to recall and use the equation work done is equals to force multiplied distance moved in the direction of the force. F is equals to, W is equals to FD. The next topic is energy resources. List renewable and non-renewable energy sources. Describe how useful energy may be obtained or electric power generated from the chemical energy stored in fossil fuels, chemical energy stored in biofuels, biofuels and biomass, hydroelectric resources, solar radiation, nuclear fuel, geothermal resources, wind, tides, waves in the sea, including reference to a boiler, turbine, and generator where they are used. You should be able to give advantages and disadvantages of each method limited to whether it is renewable, when and whether it is available, and its impact on the environment. The next topic is efficiency. Define efficiency as efficiency is useful energy output divided by the total energy output multiply 100. Efficiency has another formula, that is useful power output divided by total power output and multiply 100. So and recall and use these equations. So normally when we write these equations, the word we use here useful energy output, but here we use the word total energy input. Instead of saying output, this word is input. This is a spelling mistake. and this is total power input. Okay, so Cambridge made a mistake, I think, here, because in our normal books we use this useful energy output divided by total energy input multiply 100, and the second formula is useful power output divided by total power input multiply 100. So this word is not input, I think it's input. This word is not output, it is basically this word is basically input, and this word is also input. So you can change these words. Okay, and recall and use these equations. So I told you a mistake here. Okay, then we have the next topic is power. And define power, you should be able to define power as work done per unit time and also as energy transferred per unit time. Recall and use the equation power is equals to work done divided by the time taken. P is equals to W by T. Another formula is power is equals to energy transferred by the time taken, or you can say P is equals to delta E divided by the T. The next topic is pressure. Define pressure as force per unit area. Recall and use the equation for pressure is equals to force divided by area. Pressure is equals to F divided by A. Describe how pressure varies with a force and area in the context of everyday examples. State that the pressure at a surface produces a force in a direction at right angles to the surface, and describe an experiment to show this. Describe how the height of a liquid column in a liquid barometer may be used to determine the atmospheric pressure. Describe qualitatively how the pressure beneath the surface of a liquid changes with the depth and density of the liquid. Recall and use the equation for the change in pressure beneath the surface of a liquid. Change in pressure is equals to density multiply gravitational field strength multiply change in height. Delta P is equals to rho G delta H. So we are done with the topic number 1, and here you have noticed that there is a change in the syllabus. In the pressure, we do not have manometers here, and we also don't have the hydraulic press. So this is the topic 1, and we have completed the revision checklist for the topic number 1. If you have found this video useful, and if you have found this video interesting, and you think that this can help your teacher, your friends, your class fellows, your juniors, your seniors, please share the link of this video with your friends and with your class fellows, with your teachers. When you do this, this helps me promote my channel. I think it's a great blessing for me that I can make these videos which can touch the life of so many students around the globe. Thank you very much for watching this video and taking out time. So have a good day. God bless you all.